Welcome back. In our previous session, we explored the Git repositories, laying the groundwork for understanding how Git manages and stores project data. Today, we are diving into one of the most fundamental aspects of Git's version control, which is commits. Commits are at the heart of Git's power, allowing us to capture snapshots of our project at specific points in time. Think of a commit as a save point in your project's history, which you can return to at any given time or use to track how your project has been evolved over time. Each commit contains a complete record of what files has been changed and how they were changed, making it an essential tool for tracking the progress and health of your development efforts. This video will guide you through the life cycle of a Git commit from understanding its key or core characteristics to seeing it in action within our ongoing real-world project example called Midibooks project. We'll also cover the key commands for creating and managing commits and wrap up with some best practices to help you make the most out of this powerful feature. In future, you'll see yourself making numerous commits in your daily work as a developer or as a DevOps engineer, which becomes an integral part of your workflow to ensure precision and accountability in your project development efforts. As mentioned, a commit in Git represents a precise snapshot in your project at a particular point in time. This snapshot includes all the files and all the resources and their contents that were staged in the index at the moment you committed them to the repository. When you make a commit, you are effectively telling Git to record a new version of your project. It starts recording from that point. This version is immutable, meaning once it is created, it doesn't change. You cannot go back. So this commit is recorded and there is no edit for that commit. Each commit is uniquely identified by an SHA-1 hash, which is a 40-character string that acts as a fingerprint for that specific set of changes. This hash allows Git to track the history of the changes and link each commits to the author of that commit, ensuring traceability and accountability. This allows Git to distinguish your commit from your colleagues' commits in a distinguished manner, and it allows it to go back to any point in time when you go for searching the history. Understanding commits is essential because they form the building blocks of your project's history in Git. Each commit is linked to the previous one, creating a chain of commits, a chain that allows you to navigate back and forth through the history of your whole project. This ability is fundamental for reviewing past changes, understanding the evolution of a project, and even troubleshooting issues by comparing current states with the non-good states from the past. Now, why commits matter? Why is it important? Commits are crucial for several reasons. They serve as the building blocks of your project's history, allowing you to document and revisit any version of your project at any point in time in its whole life cycle. This capability is invaluable, very, very important for rolling back, auditing, troubleshooting, and all the troubleshooting purposes. Moreover, commits support collaborative workflows by merging them, by enabling multiple developers to merge their contributions systematically. Each commit is a commitment to a certain quality and state of the specific project, which facilitates the accountability and clarity among the team collaborators. By understanding both what commits and what are their significances, what is their significance, you can actually leverage them to maintain a detailed, navigable, and robust history of your development work, which enhances both the individual productivity of your team members and the whole team efficiency altogether. If we examine the key characteristics that define a Git commit, we can see some very interesting attributes which are essential for effectively utilizing Git in our version control process. The first one is a unique identifier. Each commit in Git is marked by a unique identifier, as we discussed earlier, based on an SHA-1 hash. This 40-character hexadecimal code acts as a fingerprint for that commit, distinguishing this particular commit from all other commits in the whole repository. This identifier is crucial for referencing specific commits from within the commands and tracking the lineage of changes throughout the whole project's history. The next attribute is the message. Accompanying each commit is a descriptive message. This message is very important as it provides context to the changes made, explaining why and what was altered when you committed in the project. This message represents a very clear and descriptive commit message, which can significantly aid in the project maintenance and the code review process. This helps all the other contributors of your code, especially your team leaders who review the changes, and even for your colleagues to understand what change has been made, why this particular change was made, and understand the purpose of the changes without having to delve into the code. So this commit message is very important in the project history. The next attribute is parent commit. A commit in a project are linked to a chain of other previous commits. Let's say a chain through their parent commit. A commit typically has one parent commit which links to its previous version of the project. However, in the case of mergers, a commit can have more than one parent. So we will discuss this specific merging functionality of merging later. Then you'll understand it better. This linkage between the commits forms a directed graph. It creates a graph which links all the commits through in the Git repository. This facilitates the operations like merges, reverts, and log displays, etc. The next very important attribute is the set of files. Each commit also records a list of files, one or more files that were modified, added, or deleted in that commit at that point in time. This list not only tracks the changes but also affects how Git handles merging and conflict resolution. By understanding which files have changed, team members can better coordinate their work and avoid any conflicts, ensuring smooth project coordination and progress. These characteristics collectively ensures that each commit in Git made by each of these team members in the whole project is a self-contained record of changes that provides traceability, accountability, and clarity within your project's development lifecycle. It's time to look at some practical examples from one of the sample projects, our popular MIDI books project. This allows you to understand how commit has been or can be utilized in a real life setup. So let's look at some practical examples how commits are used in Medibooks projects to document and manage changes made by the team members. The objective is to help illustrate the importance of clear and descriptive commit messages in maintaining a very useful project history. Okay, so let's take the example of Charlie. Charlie is a project developer. Charlie's commit. Charlie recently completed a work on a feature for the Medibooks project, which was to implement appointment scheduling with the calendar integration. So that's a typical example any developer would do, right? And after testing his changes to ensure the functionality is working perfectly, Charlie makes a commit with a detailed message that clearly describes his contributions. Implement appointment scheduling with the calendar integration. So that's the message. It's a very clear message. So within the context of the project, this helps the colleagues, the other collaborators or other contributors within the project can understand what changes has been made in this particular commit, and looking at the history they can see the evolution of the project, and then based on which they can take decisions on their respective work. Okay, so the benefit of this message is this message not only informs others of the work done, but also serves as a key piece of documentation. This message becomes a key piece of documentation of the project has been done or the part of the project done by Charlie, and this should be this is very helpful for the team to understand and revisit this feature in the future in case of any bug fixes, in case of any enhancements. So that is the main purpose of this very descriptive commit message within the project history for each commit. On the other front, Alice, who is another developer, Alice has been working on optimizing the Medibooks database. So she was working on the database optimization. After making adjustments to the enhancements of the efficiency of the user management system queries, she commits her changes. She commits a bunch of changes, bunch of files, which could be a set of scripts, which could be some codes. Yeah, and she recorded a message while she commits. She recorded a message called "Optimize user lookup queries to improve response time." Okay, So this clearly state what has been changed, what functionality has been changed, and what are the intended benefits of the changes she has made, which is the improved performance. Uh, this will not only helps in the code review, and this will become again another piece of documentation for the other collaborators within the team, and this aids in the troubleshooting and the future optimizations. Yeah. These examples show how meaningful commit messages can be, and how it helps to improve the overall productivity as well as the overall quality of your project, and how it gives a very good clarity and the context for each change. Good commit practices like these ensure that the project's history is informative and that each contributor's work is transparent and accountable. So everyone is accountable for their changes, and then everyone is accountable for making it very clear for the clarity of their code, for the benefit of others, and for themselves for any changes or any enhancements in the future. These commit messages are crucial during several phases of the project lifecycle. One such example is like code reviews. Clear messages help reviewers to understand the purpose of the changes without diving deep into the code. So, which is very cumbersome to go into the code and understand and interpret. Often, the code reviewers they misinterpret and they take wrong decisions and they reject. So, a very clearly defined clear message with clarity. This allows them to actually avoid any conflict or any misunderstanding about the code. In troubleshooting, when issues arise, developers can quickly browse through the commit history to find when a particular change was made and easily revert if it is required, if it is necessary. Furthermore, during audits or handovers to new team members, a well-documented commit history becomes a very invaluable resource, which allows newcomers to get up to the speed very quickly and understand the evolution of the project so far. These good practices like providing very descriptive commit history or commit messages, are essential in maintaining not just the current project, the health of the project, but also it safeguards its future development and scalability. Now, let's explore some of the key Git commands that are fundamental for managing commits effectively. These commands allow you to stage changes, make commits, amend previous commits, and view the commit history. Each command plays a vital role in ensuring that your project's version control is precise and accurately documented. The first one is stage changes. The command here is git add dot, which is used to stage all the changes in the current working directory. The dot represents the current working directory recursively. So starting from this current working directory, all the children directory, all the child directories will be added, staged into the version control. This means that any new files, any modifications, or any deletions that have been made within that directory and all its child directories will be prepared for the next commit. Staging is your way of telling Git that, okay, which changes you want to start tracking, including which are the changes you need to include in the next snapshot of your project, or which are ready for the commit, allowing you for selective versioning. If you are not specifying the dots, you can specify the specific files, space separated files and directories. The second command is for committing the changes, which is the actual commit. Once your changes are staged, you use the git commit with a message using the annotation dash m or minus m. Here you can put any very descriptive command, the descriptive command, which could be optimize your lookup queries to improve response time, as given in the example. And this finalizes the commit. So you stage your changes, your modifications, and then you commit with a very descriptive commit message. This command, which is the commit command, and takes everything from the staging area and it forms a new snapshot in your repository's history. This message should be descriptive, like your example. Okay, optimize user lookup queries to improve your response time. So this is a very good example that clearly tells what it does, what the code changes do. And this descriptive message helps anyone looking at the commit log in the future, whether it's your team member or you yourself in later, or an auditor or a code review person for the audit purpose, can understand why the changes were made. The third one, the next one is you want to modify a commit. So all you can modify here is, you can change the commit message. If you need to modify your last commit, for example, to correct a typo or any mistake in the commit message, or to include a small change that you forgot, you can use git commit with dash dash amend, or with the this tells git that, okay, you are amending an existing commit, the previous one, minus m with the message, which indicates the message with the updated commit message. Okay, these commands allow you to replace the last commit with a new commit that includes any staged changes and a new commit message, an updated message, ensuring your project history is both accurate and tidy. The last command in this list is to view your commit history, to review the history of your commits. This lists all the recent commits along with the ID, which is an SHA1 hash, and the author, the date, and the commit message. So this is particularly useful for tracking the progress, auditing the changes, or pinpointing when specific changes were made. So you can issue this command from any specific project or repository. So it will list all the previous history of previous commits along with all the required information. Understanding and utilizing these commands will significantly improve or enhance your ability to manage your projects from the context of Git version control system. And each command is designed to give you, very very specific control on how your project's history is recorded and reviewed and listed, ensuring clarity and consistency in your version control process. Finally, there are certain best practices for making effective commits in Git. These practices are designed to enhance the clarity, utility, the quality, and manageability of your project history, which makes it a very valuable resource for everyone involved in this project. And following this is crucial to ensure the quality of your team. The first best practice is commit frequently. Always commit very small atomic commits. Commit small logical changes frequently, make your project history clear and easy to follow. This practice of committing small logical changes frequently is essential for maintaining a clear and navigable project history. These small atomic commits should each represent a single logical change with a very clear granularity. This granularity helps in several ways. It simplifies the process of reviewing the changes by your review code reviewer or your team members, and it makes it easier to identify when a particular change was introduced, or particular change introduced an issue or an error or a bug, or an undesired functionality behavior, and it allows for straightforward reversion. Let's say you identified a bug, you identified a problem, or you identified an undesired functionality, and you wanted to revert that change. So if the changes related to that bug are scattered across multiple commits, then it would make it very hard. If it is one single commit, meaningful commit with a specific functionality, then it is easy to identify, spot that specific commit, and when you revert back to the previous state, all the related files will go to the previous state, which effectively in one shot reverts all the changes to the previous stable version. So this will allow your project will go uninterrupted, or without disrupting the normal speed or flow or productivity of your project. Next best practice is squash commits. While small commits are very invaluable, there are times when multiple small changes, a lot of changes related to the same feature or fix, can clutter your project history. In such cases, it's advisable to squash this commit into a single commit. So this happens after the initial commits. Yeah. So you can actually squash multiple commits related to a specific feature. A bigger feature has smaller sub actions, sub functionalities, and you have, let's say, 5 different commits related to a bigger feature. So it's a good idea to squash them together for the future maintenance purpose. Yeah, this approach keeps your project history cleaner and more meaningful. Another best practice is maintaining clear commit messages. The clarity of your commit messages is very crucial. The understandability. A good commit message should clearly explain what was changed and why. It should be self-meaningful, because it's essentially serves as a documentation of your change, and make it very descriptive and provide context that which will be helpful for future references. For example, a good commit message for the Medibooks project might be refactor appointment scheduling logic to improve performance and reduce redundancy. So which tells what was the purpose of that change. This is far more informative than a very vague fixed stuff or fixed bug, whatever. Yeah. So make it very informative and clearly explain what bug has been fixed, what performance improvement has been done, what was the previous problem, what problem has been solved. Additionally, using a consistent format for commit messages, so you agree within your team members that this is the format for bug fixes, this is the format for new features, this is the format for committing new components. So a consistent format for the commit messages, this will help them, easy to scan and understand at a glance. It is a best practices to include, your issue number, for example. If it is raised in tools like Jira, so there is an issue number, so always keep that issue number. That's the best practices followed in many teams. If you pick some of the examples from Medibook's project, yeah, you can see in a typical such project, you can see commit messages like, okay, refactor appointment scheduling, logic to improve performance and reduce redundancy. So it is self-explained, right? This message tells us what has been done during that refactoring, what part of the project it affects. It clearly says appointment scheduling, so it was very specific, and why it was done. It was for improving the performance and reduce redundancy. So what, where, and when, and why, it is mentioned clearly. An example for a bad commit message is like fixed stuff or fixed bug, performance improved. It is very hard to understand, so it doesn't have the enough context basically. So this message is unhelpful because it provides no context or detail, which makes it difficult for the team to understand. Then they still need to go back to that code and browse through the code to understand, and they most often they will misrepresent or misinterpret. A bad commit message will defeat the purpose of the commit message itself. By adhering to these best practices, you can ensure that your commit history, Git commit history, is very explained. It's not only a record what changes has been made, but also the whole very helpful documentation for any future developers or your colleagues or you yourself when you revisit the project for enhancement or collaborate with anyone else or for the maintenance purpose. As we conclude this video about Git commits, I hope you found these insights which we discussed in this slide as well as the whole video, and the examples shared are valuable for enhancing your understanding about the Git and the very fundamental concepts of Git commits, and related commands, and which I hope this allowed you to understand, okay, how you can help Git to track the changes and how it will help you to go back to the history and help to effectively collaborate with your team members with the power of Gits and Git commits. This foundation, these concepts are fundamental and foundational and very crucial. Is not just for using Git, but to participate to anyone who participate in the whole software development project, where version control is a key component. I, I encourage you to start practicing these techniques in your daily work. Experiment with commands which we have already discussed. Try implementing these best practices for commit messages, and make it a habit that providing very clearly defined commit messages which explains what change has been made, where it affects, and why you have done this change, etc. So follow a pattern, or if you have a policy within your organization to agree with a format for your commit message, just follow it all the time. Looking ahead, we'll build on this foundation which laid today by moving into more advanced Git concepts that will leverage the skills you have already developed through understanding the commits and the previous commands, and even the concept of repositories in the future sessions. In these future sessions, we will dive deeper into concepts like branching strategies, which are crucial for handling complex project scenarios, which are pivotal for mastering Git in a team environment, where multiple streams of development is going on, and you have different release cycles are happening, and finally you have to come back and merge and release together finally. So such complex environment, these best practices and these tools are very crucial, and we'll be discussing all of them in the coming sessions. Thank you for listening to this video. Thank you for your attention and engagement. I look forward to our next session, where we'll continue to expand the Git knowledge and skills together. Until then, happy committing.